Hi, we would like to welcome you on next webinar session. We are technical support from AC, owner of brand STAG. My name is Maciej Kuźmicz.
And my name is Marcin Grigorczuk.
And we would like to show you advanced features of STAG 400 DPI controller.
This webinar is dedicated for the more advanced mechanics who already working a lot with 400 DPI systems, and maybe we will go to the software and we will show you new advanced functions available from last release of the AC STAG software.
So new advanced functions for controlling old previous 400 DPI systems, lowering or decreasing petrol dosage in the system, or even trying to convert new engine codes which are not on the list. Maybe just a quick look what we are using today. So we are using computer with STAG software, standard STAG software, simulator, which will allow us to show you some new advanced features, and oscilloscope.
Yes. Okay, going back to the software. When we open the latest version, which is 0.46.7 of AC STAG, we have to update the controller firmware, and the latest version of the firmware is 4.0.1. Okay, we have already updated controller, and after the update we will see one new icon on the left top corner, right top corner of the AC STAG software, which is the locker, red locker. Okay, when we click on this red locker, we have information that changing advanced parameters can damage the engine components or controller itself, and we have to be aware of that. Okay, when we want to proceed, we need to click yes, and now we have information. Do we want to save the settings file from the controller to have something like a backup, which is strongly recommended by us?
Yes, exactly. Once you let's say, for example, change something and you're going to just quickly go back to previous settings, thanks to this you can do it straight away.
Exactly. Okay, and now we see that the icon changed to the green locker, and we have access to the advanced functions. Okay, and let's start from the beginning. First additional function what we see in the car parameters tab is it's a pressure emulator type. What is that? Actually, we are able to choose the way of the emulation of the petrol pressure. And for example, some engine codes on the list not using emulation at all, like for example the CDA engine code.
Yes, and let's say after conversion you have a problem with check engine light error from petrol computer about high petrol pressure or something like that. Thanks to this, it allows you to change to different pressure emulators, or even use codes which don't use emulation at all, so they just rewrite the pressure.
With some pressure emulators type, you need to choose also the same engine code to enable this pressure emulator to work. For example, if we have CDA, we should choose the CDA engine code as well. In some engine codes, this will change other parameters, which I will show you at the moment. But yeah, usually this pressure emulator type has to be changed. For example, if we have some, let's say, not supported engine code and we have some problems with high petrol consumption.
Yes. Or
it's handy function.
Or let's say you are testing new engine code and you have trouble with reading proper injection time, petrol injection time. Also, you can choose different engine codes to check if on, let's say, different engine code you can see longer, better, more stable injection types.
Okay, next parameter, which is new to us, is petrol pressure. What does it mean? This value is actually set after auto calibration. It's dedicated for particular engine codes, and we simply use that function to first to allow the petrol pressure emulator work. Let's say if we set lower petrol pressure emulator and engine codes using the petrol pressure emulators, the emulation will start working from this particular value. In our example, it will be, let's say, 1.15 volt. Everything below emulation will not work. Okay, next.
It can also have a positive effect on injection time. For
Yeah,
example, if you're struggling with too short injection time, it can also help to make it a little bit longer.
It's also affecting the gas injection dosage as well. Okay, next is advanced settings, and here we have quite important parameters for the dosing the petrol in the direct injection systems. And first of them is its cutoff delay, which simply control the petrol dosage on the while engine working on the gas. And for this we prepared the oscilloscope to show you how it's working. Okay, now let's measure the injection time. Okay, we have cursor set, yes. Okay, now petrol injection time on the petrol is around 1.4 milliseconds. Okay, yeah. And now we switch over to the gas. And as you can see, controller simply cutting the injection pulse to reduce the petrol dosage. Okay, let's measure this. And now we have something around 400 microseconds. Okay, and how it's working from the software. Let's say even if we set here 0 microseconds, still controller needs some time to processing the injection pulse, etc., etc.
Yeah, and this time will be 160.
Yeah, this time
approximately
is around 160 to 100 microseconds. Usually 160 microseconds. Okay. For example, if we set 300 microseconds, we see that this petrol injection time is increasing as well. And we have 300 microseconds set, and together with, sorry, maybe I will grab it better. Okay. Together with this 160 microsecond delay, we have something around 470 microseconds, 460, 470 microseconds, which is obvious, let's say. If we set 400 microseconds, also we increase the, sorry, my mistake. Also we increase the petrol dosage, which will be here around 570 microseconds.
Yeah, so this parameter directly pushes and controls petrol consumption.
Additional parameter which is working together with that cutoff delay is additional map in the maps tab, which is flashing map. Here we simply adding the extra microseconds depending of the load of the engine. Sometimes if there is a problem with gas injection times overlooping at full throttle or at high loads, we can manage this by simply adding more petrol, let's say from 4 microseconds injection time of the petrol. We can add, let's say, 170 microseconds of petrol, and it can help us to manage the problems with the overlooping injection times on the gas. Also, it's working in the full
range of
petrol
loads. Injection.
Yeah. And as we can see, we're adding now 20 microseconds at this point, which is simply added to that value in cutoff delay.
And to this previous 160 microseconds.
Exactly. Which is together 400, 160 plus 20, something around 500, 580. Yeah. And as we see on the oscilloscope, it's something around 580. Okay, next parameter, which is emulation delay and emulation end. These two parameters are related together, and unfortunately we are not able to show it on the on our simulator. But I have some example of screenshots from oscilloscope from other car. And here we can see the moment where usually petrol ECU checking the circuit of the petrol injector, because petrol ECU constantly checking the consistency of the circuit of the petrol injector. And usually it's a moment of transition from control from peak to hold. As far as we know, the petrol injectors are controlled by peak and hold signal type. And okay, as we can see on this oscilloscope, here is the beginning of the injection pulse, and here is the transition from the peak to hold, where at peak injector is controlled by high current, and after transition to hold there is simply PWM signal which is keeping injector open, and after that there is the end of the injection time. Okay, and now we can measure the time from the beginning of the injection pulse to the transition from peak to hold, and we are able to see that it's starting around 570 microseconds, let's say 550. Okay, and now how to use these parameters. Usually emulation should take around 200 microseconds, sometimes 300. And let's say beginning of the emulation should be around 100 microseconds before the transition from peak to hold. And we have, let's say, here 550, which means then we should start at 450 microseconds, which is already set in the software. Okay, and as I mentioned before, emulation should take around 200 microseconds, which is simply 650 is the end of the emulation. And in that particular time, injector, the gas controller will simulate injector connected to the circuit to show that the circuit is working properly. There is no problems with the circuit.
Okay, but basically for petrol consumption, controlling is not it's not, let's say, good option. It's only if you, let's say, convert new engine codes, you want to convert new cars. This is very good feature to
This feature is useful for experimenting with new engine codes, which is not converted by us yet. Okay, and there is additional parameter, which is extra injection cutoff delay. This parameter working basically same like cutoff delay, but it's related only for the additional injection pulses in the same cycle of the injection, which is extra injection. And this parameter allows to cut the extra injection pulses at the time what we set here in that area.
But only during extra injection.
Yeah, exactly. Only during the extra injection regime. Okay. Next additional parameter, actually it's not additional because it's already exists from some older versions of the AC STAG, is minimum emulated pressure. Usually this parameter don't have to be changed, but in some cars, for example, let's say Opel Zafira or Opel Insignia with 1.6 CD engine, this pressure, even in normal operation on the petrol, values can drop down even up to 0.65 volt. And to solve the problems with the fuel pressure regulator faults generated by the petrol ECU, we should drop down this value to, let's say, 0.65 or even 0.60 in that kind of the cars. This is basically the minimum value what can be shown to the petrol ECU. And right now we're using the CDA engine code, and this function will not work as it should. But let's say when we use other engine code like VAC, for example, Universal Engine Code. Okay. And same the emulator.
You want me to decrease?
Decrease, yes, please. As you can see, even when the value of the real pressure going down, you know, the controller showing for the petrol ECU the value of 0.58, which is close to the 0.6. Of course, if I increase this, controller also will increase the minimum value. And as I said, for some cars, this function is useful as well.
But by factory, let's say in our controller is set up to 0.9,
yeah,
as far as I believe.
Yeah, exactly. Next parameter what we have is minimum injection pulse. This is a minimum gas injection pulse, exactly. And what this function can do. Sometimes in some cars we need to keep the minimum injection time on the gas injectors, which allow us to open the injector properly. You know, for example, in our injectors ACW02 or ACW03, we know from practice that minimum injection time, which is allowed proper operation for the injector, is around 1.8, 1.7 milliseconds. Okay, just to show you how this function works, I will increase this minimum gas injection pulse to, let's say, now we have 3.2 point something, yes? Oh, I said 4.2, and controller will keep this time as in each value lower. Let's say controller will try to generate lower injection time, but this function will keep minimum injection time at 4.2. Yes. Usually it's lower, of course, 1.7, 1.8 milliseconds.
On this setup, the minimum gas injection time will be 4.2.
Just an example. Usually in some cars there is a problem with some floating
idling, bad idling.
Yeah, bad idle or something like that, and we can set minimum injection time, let's say for 1.8 milliseconds, which will keep injectors working properly, and sometimes it's help, you know, to solve the problems with that kind of the issues. Okay, next parameter, actually it was already in the software in previous versions, but it's always better to mention about this, which is extra injection correction. And this function simply allows us to reduce or increase the gas dosage during the extra injections regime. Sometimes the mixture going to very lean or very rich, and we need to use that parameter to maintain engine working smoothly without any interruptions, jerking or something like that. And for example, if we have too rich mixture, we need to set, let's say, -10, -15%, which will reduce the gas dosage at the extra injections regime, and allow us to maintain the proper mixture. Same story with the lean mixture. We can simply add 15, 20 even percent, you know, to maintain the mixture to be at proper level. Another parameters related to that function is enrichment intensity and enrichment sensitivity. Intensity simply tell for the gas controller how much petrol should be added during the extra injections regime, and sensitivity, it's sensitivity during the acceleration, deceleration. It's simply reacting on the changing on the map pressure, manifold pressure.
Yeah, usually that if you are struggling with some shaking during acceleration or high acceleration, this can help you solve the problem, but it will affect petrol consumption
as well.
Yeah.
Next parameter what we have actually is already mentioned flashing map. Maybe a few words regarding reducing the petrol consumption, because many workshops calling us with the problems that petrol consumption is too high or something like that. And after, let's say, few years, car was driving fine, there was no problem with the petrol consumption, but at some point service make an update of the firmware. Usually there is an information from the software that the auto calibration has to be done, and adjustments on the road has to be done as well. But many workshops simply don't do that. And after updates from much older firmwares, we can have problems with too high values on the flashing map. Let's say, for example, just to show how it usually works.
Yeah, it can
flashing map will be like that.
Yeah.
Which means that the gas controller allow to open the petrol injectors for more than 1 millisecond. Here we have 1 millisecond plus cutoff delay. It will be something around 1.4, 1.5 milliseconds, which is a lot, and it will cause quite big petrol consumption as well.
So basically, when you want to start with reducing petrol consumption, this is the place where you want to start, the flashing map.
Yeah, exactly. And to simply reduce that petrol consumption, we can simply drop this map to the 0. Okay. And let's say increase it just up to 10, let's say or 15 microseconds, or even 20. Okay, we have 15 here. And it should reduce the petrol consumption for sure. Important thing, after changes like this, we have to take the car on the road and adjust the maps once again. At least check the mixture, that there is no situations where mixture is too lean or gas injectors are overlooping, which can cause some interrupting, jerking or something like that at high loads.
Yes, exactly, but in this case, the road test is essential. When you drop the flashing map like this, it's essential because the system will be lean. That's for sure.
Yeah, it's always have to be done after modifications like this. Also, if we still have some problems with too high petrol consumption, we can try to change the petrol pressure emulator as well, to experiment, you know, that there is no issues with the fuel pressure regulator, there's no faults from petrol ECU regarding that. And it can also reduce the petrol consumption as well. The fuel pressure emulation is quite important for this as well. But not all the cars can handle this properly. They can have some issues with the fuel pressure emulator. And we not recommend to modify this parameter, cutoff delay, but for experimenting with some new engine which was not converted by us, we don't have information about this, we can try to play with that parameter as well. Also, this parameter, if it will be too low, it can cause the problems with the injector circuit open, recorded by the petrol ECU, and we have to have this on the mind as well. Then sometimes too much reduction of the petrol dosage can cause problems like this.
Yeah. That's why also road test is essential. Not only idle test, but also taking the car on the road and checking everything.
Exactly. Okay, the last thing what I want to mention, there is a injection retarding map. It's actually retarding the moment of the gas injection. Normally, with regular car converted from the appendix, this injection is shifted by 180 degrees of the crankshaft revolution. And simply changing some values here on the map, we will shift the gas injection moment by another value, let's say 90 degrees. And it means then all injection pulses, gas injection pulses, will be shifted by extra 90 degrees, which is 270 in that case, when the engine will work in that area of the load. Why we need to use that map? Sometimes some cars have some problems with some interruptions in low loads or high loads or something like that, and this map can help to maintain engine working smoothly, but it should be used as experimenting. Simply, when you have a car like this, you have to experiment with these angles, and you will simply see the difference while driving. Usually this map should be untouched. Maybe a few words about the experimenting with new cars. Many workshops trying to experiment with cars which was not converted before, and usually to do not have some problems with disassemble the system because the system simply couldn't work. They install wiring and controller to check that the controller will not have problems with the reading injection pulses, etc., etc. After that, they install the injectors, the reducer, and check how it's work on the gas, if it's passed the auto calibration or not, or they have to do some modifications here in the settings. And if they maintain the engine running fine on the gas, they simply doing some short test drives to see that everything working fine, and after that they fitting the tank, the filling point, and finish all.
And test petrol consumption, which is also important in this case.
Yes, yes, but usually they trying to reduce, you know, the petrol portion already doing the test drives.
Yeah, but in this case, having an oscilloscope is an essential thing for me.
Oscilloscope is very crucial because we have to check the injection pulses before maybe the petrol controllers have some exotic way of control the injectors or something like that. And always it's better to check this before the conversion like this. And without the oscilloscope, it's not possible, simply.
Yes.
Also, yeah, as I mentioned at the beginning, by reducing petrol dosage too much, we can simply cause quicker degradation of the petrol injectors, which is also has to be on the mind, because petrol injectors are quite expensive. And if they dying at a very short period of time, I'm not quite sure that it's point to play with the settings like this.
That's it for today. Thanks for joining us on this webinar session. If you have any other additional questions or anything you want to ask us about, don't hesitate, write emails, ask us on Facebook, or just a comment under this YouTube movie. Thanks.
Thank you, and see you next time.